The following presentation contains audio. Please make sure your speakers are enabled. Thank you for attending this presentation. Wellray Medical Laser is excited to be welcomed here today. We are confident you will agree that laser therapy is the future of medicine. Good morning. I am Richard D. Roberts, CEO of Wellray Medical Laser. We are based in West Virginia, and our company has more than 6 decades of electronic design experience. This presentation is the second of 2. The first presentation was an overview of the SoftCure 96 laser therapy system. In this presentation, we will cover the mechanism of action of laser therapy. There are 3 primary areas where laser therapy can complement and enhance the body's immune response to pathogenic infection and physical injury. LLLT decreases the inflammatory response, increases phagocytic capability, increases mitochondrial performance, and quickens and strengthens the healing process. Inflammation is part of the immune response to injury of the body. Inflammation begins with the innate immune response and continues with the adaptive immune response. This slide is a simplified representation of an immune cell, showing only the organelles necessary for our discussion. The innate immune response is initiated by toll-like receptors stimulated by pathogens or physical cell damage. Bacteria and viruses are called pathogenic associated molecular pattern, or PAMPs. Cell contents, such as ATP, DNA, or RNA, when released by cells, indicate cell injury and are called danger-associated molecular pattern, or DAMPs. When either DAMPs or PAMPs are detected by the toll-like receptors, they activate cell transcription factors AP1, IRF, and NF-κB, which produce pro-inflammatory cytokines, interleukins, TNF-alpha, and interferon. Node-like receptors also detect PAMPs and DAMPs. Node-like receptors form inflammasomes, which activate procaspase-1, forming caspase-1. Caspase-1 in turn promotes pro-inflammatory cytokines, which fully activate cytokines. The activated cytokines initiate a cascade of inflammatory processes. Phospholipase A2 converts phospholipids from the cell wall into arachidonic acid and platelet activating factor. Lipoxygenase converts arachidonic acid into leukotrienes. Cyclooxygenase, COX, converts arachidonic acid into prostaglandin PGF2A, PGD2, PGE2, PGI2, and TXA2. Interferon activates inducible and mitochondrial nitric oxide synthase, which produces nitric oxide. These products, eicosanoids, prostaglandins, and nitric oxide, cause vasodilation, hyperalgesia, bronchoconstriction, myometrial contraction, and inhibit platelet aggregation. Many pharmaceuticals are in use to mitigate these inflammatory processes. Steroid injections mimic the adrenal gland's secretion of cortisol, inhibiting the production of PAF and arachidonic acid. There are also leukotriene antagonists, prostaglandin antagonists, and TXA2 antagonists. The most widely used drugs are non-steroidal anti-inflammatory drugs, NSAIDs, such as aspirin, Excedrin, Advil, Motrin, Aleve, etc. There are also COX-2 inhibitors. There are also anti-TNF-alpha agents. LLLT reduces the production of TNF-alpha, interleukins, and interferon, thereby blocking the entire inflammatory chain. The fact that LLLT can reduce inflammation and pain by blocking the entire inflammatory chain presents the possibility that LLLT could alleviate the nationwide epidemic of prescription opioid analgesic abuse. The second primary area of action of LLLT is anti-pathogenic response. In order to discuss the antipathogenic response, we need to examine the mitochondrion. Mitochondria consist of an outer membrane and an inner membrane surrounding the matrix. The primary job of the mitochondria is to produce adenosine triphosphate, ATP, which is the molecule that carries energy for the synthesis of proteins and membranes, movement of the cell, and cellular division, etc. Cells are full of mitochondria. This is a microphotograph of a cell showing the nucleus, blue, and mitochondria stained red. ATP is produced by a set of enzymes on the inner membrane called complexes. Electrons are passed from one complex to the next. In the process, electrons escape from complex 1, 2, and 3, converting oxygen into superoxide. Superoxide plus hydrogen protons are converted into hydrogen peroxide by superoxide dismutase. Hydrogen peroxide is the main killer of pathogens in phagocytes. So in the normal process of creating ATP, the killing chemical hydrogen peroxide is also produced. In order to protect the mitochondria from the hydrogen peroxide it makes, the cell depends on glutathione peroxidase and catalase to convert hydrogen peroxide back to oxygen and water. LLLT will excite oxygen to form singlet oxygen. Singlet oxygen plus water forms trioxidane, which combines with water to form hydrogen peroxide. This increases the amount of hydrogen peroxide available for phagocytic killing of pathogens. Interferon activates MT-NOS to produce nitric oxide. NO reacts with superoxide to form peroxynitrite, which is converted to create several other reactive nitric oxygen species, RNOS. RNOS are used by phagocytes to kill pathogens. NO also activates NFKB in other cells, initiating an inflammatory response in immune cells which have not detected DAMPs or PAMPs with their toll-like receptors or their nod-like receptors. Complex 1, 2, and 3 of the electron transport chain pass electrons to complex 4 called cytochrome C oxidase. They also pump hydrogen protons into the intermembrane space. The protons are forced through complex 5 to produce ATP. This whole process is called mitochondrial oxidative phosphorylation. Nitric oxide binds to cytochrome C oxidase, complex 4, reducing ATP production by 27%. LLLT dissociates nitric oxide from cytochrome C oxidase, restoring ATP production. This makes the immune cells better able to kill pathogens and fulfill all other immune response activities. The third primary area of action of LLLT is wound healing. Wound healing progresses through 5 overlapping phases. We have shown how LLLT can limit inflammation and restore mitochondrial performance. We will now address wound repair. An increase in cell mitosis means that new cells are produced more quickly, replacing damaged cells. This cell proliferation is supported by enhanced blood vessel development. Collagen, fibroblasts, keratin, and other structural proteins are produced more quickly because of energized growth factors. We experience the effects of light every day. The molecules in our body respond from ultraviolet through the visible range into the infrared. Melanin turns dark to protect the skin. We get most of our vitamin D from exposure to the sun. We can feel the sun's rays as heat on our skin. Of course, without light, we could not see. Light energy in the form of photons strike electrons in the outer shells of atoms and excite them to higher electron energy shells or states. When an electron is excited by a photon, it can rise to a higher state of energy. After a small amount of time, it will give up its energy and return to the ground state. It gives up its energy by emitting a photon or by internal conversion, which makes the atom rotate or vibrate. Photon emission is either fluorescence or phosphorescence. Photon excitation or mechanical collision can cause molecules to rotate or vibrate. A word about quantum effects. Laser light and lead light are both used for LLLT therapy, but laser light is acknowledged as having a better effect. It penetrates body tissue to a greater depth, and it affects mitochondria to a greater extent. The latest theory for this is that because laser light is coherent, it causes quantum coherence in the cells and thereby initiates quantum superposition and quantum tunneling. This increases the rate of photon and electron transfer, upregulating cytochrome C oxidase. The National Institutes of Health has declared prescription drug abuse to be a serious national problem. Prescription drugs lead to non-medical use of opioid analgesics and heroin. This abuse creates dependence in the users and tolerance, which requires more drugs to achieve the same effect. There are many people who cannot take pain pills because of existing medical conditions. There are also people who refuse to take opioid drugs because of the side effects or because of circumstances in their lives which preclude them being able to take them. The Soft Cure 96 can reduce inflammation and pain by blocking the entire inflammatory chain, thus reducing the requirement for prescription drugs. This ends the second presentation on the Soft Cure 96. Thank you for your attendance and interest in our laser therapy system.